Well, good morning, guys. I hope you're there. There are a few learners waiting. I think we can start. No? I don't know. I had some issues with the sound this morning, so I have to fix it, and it took me quite long to fix the sound because I didn't know what was the problem, and it was a lot of noise. I noticed in the last stream I did, and then I struggled to find the problem, so that's why I started a little bit late. Okay, but we can do the question. I tried to look at the question this morning very early, and it's a very good question. It's a very good question. It's a question from grade 12. It was in one of the grade 12 question papers previously. Okay, so I think we can start, and let's see how far we go. If there's any issue, please, you can write a message. So I know you are seeing properly and you are hearing properly the video. Just let me know if there's any problem, please. Okay. So now the question. We are here in the question. The question say a 5 kilogram block resting on a rough horizontal table is connected by a light inextensible string passing over a light frictionless pulley to another block of mesh 2 kilograms. The 2 kilogram blocks hangs vertically as shown in the diagram below. And then you have here the diagram that show you the situation. You have a block here, 5 kilogram block connected to 2 kilogram block on that specific side there. All right. Now moving on. Yes. The coefficient of kinetic friction between the 5 kilogram block and the surface of the table is 0.5. Ignore the effect of air friction. So they're giving you the kinetic coefficient of friction for between the 5 kilogram block and the table. Okay. So they're giving you that one there. Let's see. Draw the label free body diagram showing all the forces acting on the 5 kilogram block. Note the following. In this question, they are telling you there are 5 marks. It means there must be the 5 forces. Okay? The number of marks is related to the number of forces you have to do in here. So let's quickly go and answer that question. Let's answer the question here. I did struggle today a little bit with the setting. Okay, so now we have a 5 kilogram block. Now on the 5 kilogram block, there are 5 forces acting. First of all, the one that you can see clearly is the applying force that forms an angle with the horizontal. This one here is the applied force. Okay, that one is the applied force. I think you can see properly there. What other forces are acting on the 5 kilogram block? If we go there and look again, guys, and we look again real fast, you can see here there is also the tension that you can also see it easily there. There's also the tension pointing to the right. Okay, so the tension pointing to the right. This is tension. There is also gravitational force pointing straight down. There is normal force perpendicular to the surface, which in this case, the surface, let me move it a little bit down here. There we go. Which in this case, the surface is horizontal, and there's another force, which is the frictional force. You can draw it along the same line here. So we can draw it if you want there and say frictional force. Okay, you can do it on the same line, or you can do it slightly up or down. It doesn't really make a difference in here. Those are the 5 forces acting on the block. So if you do that one, you are going to get 5 marks, 1 mark per force. So it's 1, 2, 3, 4, and 5 marks. You cannot include the component. Remember this year they released a note saying that if components are included, you are not going to get marks at all. So that one is very important, guys, to know as well. Okay, I just want to know if there is not a question. Nobody's asking a question yet. So I hope that one is clear for you all. All right, it's very important. Now, later on in question 2.5, we have to calculate the acceleration. In question 2.2.1, we have to calculate the components. So I am going to include the components, but note This one is like in an extra free body diagram you would do. Okay, so here, this force will have or project to the horizontal surface, and you will have here the applied force in X. Remember, once more, you cannot do it in a free body diagram. If you do that, you are going to lose the marks. Okay, so that is the applied force in the X direction, and if you project that force in the vertical, you will have here, at this point here, you will have the applied force in the vertical direction. They are giving you the angle between the applied force and the horizontal. This one here is 10 degree. We are going to use it to do calculations just now that they ask. Okay, but those two components are not part of the free body diagram, and therefore you cannot include it. All right, so that was question, let me see, question 2.1. Remember, the components are not part of that specific free body diagram. Now, question 2.2, calculate the magnitude of the vertical component and the horizontal component in question 2.2. You need them, even if they don't say calculated, you are going to need it eventually, because you're going to calculate acceleration later on. Okay, so it is quite important. Let's quickly solve those questions here. Trying to look, I hope there's no issues. Yes, let's solve that question real fast. Calculate the vertical first and the horizontal. I'm going to do it here on the right side because I'm going to need it eventually. So here I'm going to calculate, this is question 2.2.1, all right? And we're going to calculate the vertical component. In other words, the applied force in the y-axis. Applied force in the y-axis will be equal to applied force multiplied by the cosine theta. If we go to the drawing here again, you notice that the horizontal component is the adjacent side to that 10 degree. This one is the adjacent side. Okay, I'm going to write here adjacent side. And therefore, if you use the mathematics, is cosine. All right, so here, we get here, when you substitute the force is given to you, you get that this one is equal to 60 multiplied by cosine of 10 degree. The answer is 10,42 Newton. That is the horizontal component of the force. I hope everything goes well. I hope you have not questions there. You can always ask for a question if you don't understand something, okay? Let me see. Let me see if I see any question. There's no question. Okay. All right. We can move on. We can move on. We're going to solve now question 2.2.2, which is calculate the horizontal component. All right. Question 2.2, calculate the horizontal component. 2.2.2. Calculate the horizontal component is this force that we have here. This one is the opposite side to the angle. That one corresponds to this side here. That one is the opposite side to that specific angle. So we use the sine of theta. So the applied force, the applied force in the x direction is equal to applied force multiplied by sine theta is the opposite side. Let me just fix this one here. There we go. Sorry, there we go. There we go. So this one is sine theta in there. Okay, there we go. Sorry, it's difficult. Today I've been struggling with this setting. Applied force multiplied by the sine 10 degrees. Because the angle is 10 degrees. So if you substitute here, you have that the applied force in x is equal to 60 multiplied by sine 10 degree. And then this one gave 59,09 Newton. That is the applied force in the y direction. Okay, that is the applied force in the y direction. Once more, if there's any question you can ask quickly, I'll answer your question. Okay, so it's fine. we can move on to the next question. We can move on to the next question, okay? The next question said, let me show the question here to you guys. The next question said, state Newton's second law of motion inward. Now for this one, I draw the examination guideline for the grade 12. There is the Newton's second law, right, of motion. So when a net force acts on an object, the object will accelerate in the direction of the force. The acceleration, and then we are at this point here, the acceleration is directly proportional to the force. Then you will get 1 mark for saying that part in here. So if you get that part, let me see if I can get maybe a red color for you all. So here, if you do that, you get 1 mark for saying that, and then the other part that will give a mark will be this one here, and inversely proportional to the mass of the object up until there, that will give you the other mark. That is Newton's second law of motion. You need to get that definition because it's for sure 2 marks and is high probability of being in the exam. All right, one of the Newton's law is going to be there. Question 2.3, 2.4, calculate the magnitude of the normal force acting on the 5 kilogram block. Now we are going here, and that is why I include the components in the question, or in the free body diagram. We have to calculate the normal. The normal force, guys, note it is on the y-axis. So we are going to calculate normal using the forces that are on the y-axis. Let me mark here. Let me see if you can see properly there. Yes, those are the forces on the y-axis. So to calculate normal, I am going to apply Newton's law in the y-axis. The object is not moving, or that object is not moving on the y-axis. All right, therefore, I'm going to apply Newton's first law. F net is equal to 0. This one is question 2.4. 2.4. Okay, this is my cat playing there. 2.4. Now here we have, what forces we have there? We're going to take up as positive. All right, we have the normal, plus we have the applied force in the y-axis, minus gravitational force because it's pointing in the opposite direction. That is equal to 0. All right, so here normal is equal to gravitational force minus applied force in the y-axis. And we have these values. The gravitational force, we can calculate it. Let's do it here. mg minus applied force in y, we already calculated in there. Okay, so this one is minus applied force in the y-axis. Now the rest is to substitute the numerical values. This one is 5 multiplied by 9,8 minus 10,49. We get that the normal force is going to be equal to 38,58. 38,58 Newton. That is the calculation of the normal force. I don't know if it's maybe blurry. There we go. That is how to calculate the normal force. Any question in relation with normal force? Any problem with normal force? No? Okay, so we're going to move on, and now is the most difficult part, which is to calculate the tension of the string. We're going to calculate the tension of the string. This question now say, we go here, it say calculate the magnitude of the tension in the string. To calculate the tension, we have to use simultaneous equation. All right. So we have to apply Newton's second law on both objects. Let's start here with Newton's second law for the 5 kg. So let's begin with the 5 kg, and we are going to apply Newton's second law. So what forces are acting there? We have F net is equal to ma. That is Newton's second law. You start from there. All right, we're working in the x-axis because the object is moving in the x-axis. We have the applied force in x, we have the frictional force, and we have the tension. Right, left is positive because the object is moving left. All right? So here we have that the applied force in x minus friction minus tension is equal to MA. All right. The applied force in X we already calculated. The frictional force, we don't have it. We can calculate friction now. Friction here is equal to kinetic coefficient of friction multiplied by normal. And we do have the normal, right? So all we have to do is to substitute here to calculate the frictional force. The kinetic coefficient of friction is 0,5, so this one is 0,5, multiplied by the normal, which we calculated, and it's 38,58. 38,58, we get that the frictional force is going to be equal to 19,29 Newton. That is the friction. So now we take that friction and we substitute in here. All right? We substitute in there. Then we have everything. Now we have all the numbers to substitute and get equation 1 because we're going to have 2 unknown anyway. Right? Let me just go here. There we go. All right, so let's go to this part. So now, the applied force in X, we calculated, it was 59,09. So we substitute 59,09, all right? Minus friction, we just calculated, is 19, I just checking my calculations there, 19,29. 19,29. I don't know why this is so thick. This is a 29. Let me just clean here quickly. 19,29. There we go. Which is friction. Minus T. We don't know T, so we keep it unknown. Equal to the mass, which is 5, 8. We have 2 unknown, but we have a common factor here. Right, we have this and we have this here. Okay, so when you solve that one, you will get that it's 39,8 minus T equal to 5,8. And we cannot move on because we have 2 unknown here. We don't have tension and we don't have acceleration. We're going to call this one equation 1. All right, so we have now equation 1. We have to do the same for equation 2. So we have to do the same with the other object. Okay? No. Did I? No. I got 10.43 for the y-axis. Okay, I'm going back to this equation about the answers in 2.2.1. When you go to 2.2.1, quickly, let's go there to 2.2.1. Say calculate the vertical component. The vertical component got 10,42. Let me see my answer here. My answer here is 10,42. For 2.2.1, it's right, it's right. And 2.2.2 calculate the oh, I see what you're saying. I substituted on the sine and the cos. Yes. Oh my goodness, and I have the answers there at the front. This is sine here. Thank you. Who is this one here? Kali. Thank you, Kali. Yes, this is sine here. This is cos here. Sine and cos. Yes. This is sine here. Sine 10. This is cos 10. Sine and cos. You are right. The answers are still the same because I did calculate it before. I just have it in front, but I'm missing words. You know I miss words, guys. Yes, thank you. You're right. Yeah? Okay, I hope it's that clear. I'm sorry, guys. Let me see if there's anything else. Okay, yes. Right, so that is sorted now. Yes, I make a mistake there with the sine and cos at this point here. Okay, this one is sine here. This one is cos. Sine and cos. Okay. Yes. So now we're going to continue here. So we're going to apply the Newton's second law for the object that is hanging. All right. For the object that is hanging there, let's say for 2 kg, what forces are acting there? We have tension up and we have gravitational force down. Gravitational force is smaller than tension because the object is actually moving up. So here is accelerating up. Here is gravitational force. So those are the two forces acting on that block there. Okay. Let me see if I can move my face here so we can use that side there. Okay. So now here we're going to apply Newton's second law on this object, which is the 2 kilogram block. We have F net is equal to MA. All right. You can still not see there. Let me move it a little bit there. All right. And now here we have the forces are up positive. The object is moving up. So it's tension minus gravitational force is equal to MA. We have the tension minus mg is equal to MA. If you substitute, you got the tension minus 2 multiplied by 9,8 is equal to 2A. There we go. All right. This one is going to be tension minus 19,6 equal to 2A. There we go. And then we stop there because we cannot continue. This one is going to be equation, this one here is going to be equation 2. All right. So that one is equation 2. Now we have to add the two equations. We add in the equation, guys, to calculate acceleration. We're looking for tension, but we cannot calculate tension if we don't have acceleration. That is why we are going to add the two equations now. So we have now here, let me move this one a little bit up so I can answer there. There we go. So here we add 1 and 2. All right. So we have 39,8 minus t plus t. I'm adding the two equations. You can use substitution if you want. It's entirely up to you. Plus t minus 19,6 equal to 5a plus 2a. There we go. The tensions will cancel each other. And with this one, you calculate acceleration. So I got for acceleration, when I solve this one, 2,89. Right. So the acceleration here is 2,89 meters per second squared. That is the acceleration. Any problem there? Any question there? No questions? All right, so now we are almost done. All we have to do is to substitute the acceleration in one of the two equations. I personally substituted in equation 2. I think it's easier, but two of them are very much the same. So all you have to do is to substitute the acceleration there. So we get the tension minus 19,6 is equal to 2 times the acceleration, which is 2,89. 2,89. Tension is going to be equal to 25,38. And that is the question. I think this question was not that difficult. I don't think that question was that difficult or that of a big problem. It was actually, I think, easier than other questions we've been solving here. But now we're done, guys. That is the question. I want to know if there's any problem. I want to organize some questions that more or less can help you with the exams. This one can help you with the exam. All right? There is a question on two blocks. On two blocks in a system. Now, any question? Any question? before we finish. I don't know how long are we going now. It's around 26 minutes, yes. I don't want to make the streams too long. So, any question, guys? Yeah, in case of this one here, I didn't swap the answers, I swap the questions actually. I calculate wrong that one there. Okay? So I don't know if there is any problem. Okay. Okay, guys, so no, then we are done. We're done. Just if there's no questions or anything, then we are done. I hope it helped. We have to see because the exams are starting soon and there's little time for this. Okay? So, I don't know. Anything you want to ask or say? Then we are done. Well, guys, thank you for watching. Enjoy your weekend. Study a little bit. Have a wonderful Mother's Day tomorrow. Say Happy Mother's Day to your mother from my side. And then I'll see you next time. Thank you for watching. Next time we'll see what question we can solve. Okay? Thank you.